11.1 is about your formulas. The first thing I want you to do is go to page 11 in your unit guide and look at this page. These are the formulas that you will be given on the test the way that they will be given. Make sure that any other formulas you feel like you need to know are in your brain. There are a couple changes I want you to make on this page, so scroll down here. When we're talking about lateral surface area, I want you to change these S's to L's just so we don't get confused with lateral area and total surface area. The other thing on your prism total surface area formula, we forgot the bases, so we need to add plus 2, and that should be a capital B, not a lowercase b. Okay, so now what I want you to do is go to your 11.1 notes, which start on page 15. The first section of the notes are what I like to call nonsense formulas. These are formulas involving things that do not really exist, but they make you focus on how to use a formula. So let's look at the first one. You can use the formula F equals 3G plus N to find the number of Flegels you can produce using Norts and Newlands. If you have 5 Norts and 2 Newlands, how many Flegels can you make? So let's focus. We have 3 variables. We have an F, a G, and an N. So let's figure out what we know about each one. It tells us that we have 5 Norts and 2 Newlands, and we're trying to figure out how many Flegels we can make. So when I take this formula, I'm going to rewrite this F equals 3G plus N, but I'm going to substitute in the values that I know. I don't know the number of Flegels, so I'm going to leave that in F. G is going to be 5, and N is going to be 2. From here, I just need to do my calculations. So this would be 15 plus 2, or 17. Final step will be to answer the question. It's not just 17, it's 17 Flegels. So make sure that you include your units all the way through this unit. The labels and units on your answer will be very important. All right, so let's look at the next one. This one, it tells us that we made 26 Flegels. And we don't know the number of Norts, but we did use 8 Newlands. So when I write my formula, I'm going to substitute 26 for F. I don't know G, so I'm going to leave that as a variable. And N is 8. So when I go to subtract, I'm going to get 18. And then we divide, and we find out that G is 6. So to answer this, I would have 6 Norts. All right, let's look at the next nonsense formula. This formula can be used to find out the pounds of pling you can produce using blit, which is measured in inches, and yarp, which is measured in pims. So we need to figure out what our P, B, and Y all represent. So it says how much pling, so we don't know that, can you make from a foot of blit. Now if you notice, blit is measured in inches. So when this says a foot of blit, this is going to be 12 inches. And we have 3 pims of yarp, so that's just going to be 3. So here's your formula. And we're going to substitute in what we know. We know that B is 12, and we know that Y is 3. So we're going to do our calculations. 12 minus 4 is 8. Half of that would be 4. 5 times 3 is 15. So we get 19 for our answer. So this is 19, which is the P. P is pling, and it tells us that we have pounds of pling. So this is going to be 19 pounds of pling. I want you to set up the next one, stop the video, work through it, and then turn the video back on to see if you're correct. And you should have 10 inches of blit. So this leads us to our steps for using formulas. The purpose of doing the nonsense formulas is to think through what you have to do without relying on, oh yeah, I know how to find the area of a triangle. You'd be surprised the number of times you misremember a formula. So our first step is going to be to choose the proper formula. If it's asking for area, you're going to choose an area formula. The problem we sometimes have is when it asks for things like the radius. So we don't have a formula for radius because it depends on if you're talking about circumference or area. So you need to put some thought into choosing the proper formula. Once you've done that, you're going to substitute in your values into your formula and solve what you have to find whatever piece is missing. Always do step 4, which is to answer that question using the proper units. All right, so let's go through a couple special notes. These are things that you need to be aware of every time you're doing formulas. The base and the height are always perpendicular. Okay, so this would be my base and this would be my height. The base has nothing to do with what it's sitting on. If I have a triangle, nope, don't want to do it that way. If I have a triangle that looks like this, then I'm going to make this my base and this my height. Okay, even if it's sitting this way, if this is a right angle, my base and height would look like this. This is true for three-dimensional figures as well. So if I have a rectangular pyramid, my base is a rectangle, my height has to be truly perpendicular to that. It would be the height in the middle. For prisms and pyramids, the first part of the name is the base. It doesn't matter what it's sitting on. If I draw a cylinder this way, it's still a cylinder. My base is still a circle, even though it's sitting on the rounded side. Okay, so if I draw, the biggest problem comes with things like this. So if I have a triangular prism and I have it laying this way, it's sitting on a rectangular side, but my base is still the triangles. Your bases, if you have more than one, are always parallel to each other. So if you have two parallel sides, those are going to be your bases. The next one deals with our regular polygons. The apothem is the perpendicular segment that joins the center of the polygon to the midpoint of one of its sides. So let's say I have a pentagon. My apothem is going to go like this. When you're using formulas, sometimes you'll see part of the formula that's capitalized. This is why I emphasized capitalizing the B earlier. The capitalized part needs to be done first and separately. Once you've computed the capitalized part, you can bring it back to the rest of the formula and finish your calculations. If you do this in this manner, formulas are really easy to use. So let's go through this example here. It says to find the area of a hexagon with sides of 4 inches and an apothem of approximately 3.5 inches. So you're going to look up the formula for the area of a hexagon, and you're going to see it says 1/2 lowercase a capital P. So I have a capital P. So I'm going to come off to the side and calculate that. P is the perimeter of my hexagon. Hexagon has 6 sides. Each side is 3.5 inches. So when I go do this, sorry, that was the apothem. Each side is 4 inches. So my perimeter would be 24 inches. Now I can bring this number back into my formula and calculate. My apothem's 3.5 inches. My perimeter is 24 inches. And I'm going to go calculate this and find out that this is 42 square inches. That brings me to my discussion of units. Length, like of the side, base, or diagonal, perimeter, circumference, radius, diameter, apothem, height, all of these use linear measurements. If you can measure it with a ruler or a straight object like that, you're dealing with a linear measurement. Area, lateral area, surface area, these always use square units. Okay, and there's some examples listed there. Volume is always in cubic units. Your symbol, the little tick marks, we use a single one for feet and double for inches. The way I always remember it is to think of the plural of the word. Feet has 1 syllable, inches has 2, so we use 2 marks. You can't use those marks, however, if you have square inches or square feet, because it just doesn't look right. Also, make sure when you're using the exponent for your square inches or cubic inches that you put it on the inches or whatever unit you have. All right, so now what we're going to do is we're going to do some practice problems. I'm going to walk you all the way through one, and then I'm going to have you turn off the video and work the next couple on your own and turn it back on to check it. The first figure we're looking at is a trapezoid, and we're asked to find the area. So we're going to go look up that formula for the area of a trapezoid, and it looks something like this. And so now I have to figure out what all these pieces are. Well, I'm noticing these marks telling me those two sides are the same length. So even though they don't look like it, I'm going to take those to both be 3. So now I'm going to substitute in what I have. My two bases are 3 and 7 because bases always have to be parallel to each other. My height has to be perpendicular to my bases, so that's going to be this 3. At this point, we just calculate. This is going to be 10. Half of 10 is 5. Times 3 is 15. And then we always answer using proper units. So we would get 15 square inches. This next figure is a rhombus, and you would need to be told that, but I'm telling you it is a rhombus. So what I want you to do is stop the video, go work these two out, and then check them. Okay, so you should be checking your rhombus and your triangle to make sure that you did those correctly. Stop the video if you need to make corrections. Otherwise, we're going to go ahead and go on and look at these lateral area problems. This first one, because the base is a pentagon and it comes to a point, is a pentagonal pyramid. So what I want to do is look up the formula for the lateral area of a pyramid, and what I'm going to find is L equals 1/2 PL. Okay, so my lateral height is the slant height on the side. My true height, the one we use H for, is the perpendicular height in the middle. This formula is going to use our lateral height. I'm seeing this capital P, which means I need to go off to the side and calculate that. My base is my pentagon, so it has 5 sides, each of which are 11.6 feet. So this gives me a perimeter of 58 feet. So now I'm going to continue with my formula and bring the 58 feet back in and my lateral height, and then do my calculations and get 493. So this would be 493 square feet. Stop the video, and I want you to do the next two figures, and do understand that on this one we're going to take this to be the base. Okay, you should have your 12 pi square meters for your cylinder. Make sure that you leave answers in terms of pi. Don't multiply in 3.14 or even use the pi key. Just leave it in terms of pi. And for your rectangular prism, your height has to be the 7-inch side because that's perpendicular to what we're calling our base. You should be getting 518 square inches. At this point, I want you to stop this video. There is a second video for this unit. It's much shorter because we're just going to go through a few more problems. But you do need to start that to finish your notes. If you don't go on to the second video, you will not have full credit for your notes when your teacher checks them.